All right, here we go. So these are the inequalities that we're talking about, okay? The first one, it looks like a sideways L, and it is, does anyone remember? Is less than. I'm just putting the name of it above. Now, if it's less than, and I'm going to jump to the bottom row, where are you going to shade when you have either a solid line or a dashed line? If it's less than, you're going to shade below, yes. Below the line, or low, or under, or whatever you want to put. Okay, under the line. Now I'm going to jump over here, and this one with the is less than or equal to, less than or equal to, I should have written that up at the top, is less than or equal to. That also, because it's the is less than, you are going to shade below the line. Okay, keyword being below. Then we also have, in the middle of those, is greater than, and if it's greater, it's higher, it's up. So you're going to shade above the line or on top. And finally, the last one is greater than or equal to, and you are going to shade above the line for that one. Because it's greater, it's on top. All right, now, which of these inequality signs look similar to an equation or an equal sign? Which of these looks the closest to an equal sign? The first, second, third, or fourth? The first sign looks kind of like an equal sign. Third, yeah. Why does it look like an equal sign? Because it's got the little dash there. It's got part of that, right? So anytime you have this bottom part with the equal sign, what kind of line are you going to draw? It's going to be a solid line, just like when you do an equation and you graph an equation. It's always a solid line, right? Does that make sense? Remember, you guys can shake your heads. Yes, makes sense. No, I don't get it. And the is less than or greater than does not have part of the equal sign. So this is going to be a dashed line. A dashed line. Does everybody know what a dashed line is? You've got breaks in between. That's your dashed line. Over here, it's solid. Okay? Questions about that? All right, so here we have an example for a linear equation. How? Yes. Oh, yeah. We have a linear equation. I know it's linear because my variables have a 1 understood on it, okay? We need to put this in slope-intercept form. Slope-intercept form is, just to remind you, y equals mx plus b. That is slope-intercept form, okay? So I need to move some values from this original inequality. So I'm going to rewrite it down here. 12 minus 4y is greater than x, okay? Notice the y is still on the left side, okay? So I'm going to put this right here. I'm going to keep the y form right there. I need to move that 12. How am I going to move that 12 mathematically? Yeah, I need to subtract it. So subtract 12. And whatever you do on one side of the inequality, you do to the other. Subtract 12. The 12s are going to cancel out. And don't forget, Hector, we need to bring down that negative sign. So negative 4y. Hector, you with me? Hector. Are you okay? Okay. Well, you were looking over there. I was like, oh. Don't forget that negative sign. So negative 4y is greater than, can I combine x minus 12? Are those like terms? No. So you just write it out horizontally, x minus 12. I am trying to get y by itself. Right now, y is being multiplied by negative 4. We want to undo that. So I am going to do the opposite of multiplication, which is to divide. And I'm going to divide every term on the right-hand side. Okay? And I like to put dividing by negative 4 under each term. So what happens on the left? Negative 4 divided by negative 4. That's going to simplify to be a 1. 1 times y is y. We divided by a negative. Wasn't there something we were supposed to do when you divide by a negative in an inequality? You've got to flip the sign. Yes. So now it's not greater. It is less than. Okay? Is less than. Now, I cannot take x and divide it by negative 4. That's not a like term. So I just have to write it as it is. I'm going to put the negative up here, and I'm also going to put a 1 in front, just because that's going to help me. So it's negative 1/4 times that x, okay? And I'm just going to put the x there beside it. And the last term, look at this, I have a negative 12 divided by a negative 4. Negative divided by negative is a positive 3. So now this is in slope. And look at it, slope-intercept form. Slope comes first, then the intercept. So this is your slope in front of the x, and this is your intercept. So the slope is negative 1/4. And the b, that's your y-intercept, that's that constant number by itself, is 3. That was a lot. But you guys have done this before? Most of you? Kind of, maybe? Okay. All right. Now, let's start with, we need to graph this. But remember, it's an inequality. So I am going to graph, just like it was an equation, you're going to graph your constant first, your y-intercept. That's 3. That's 1, 2, 3. Y-intercept is on the y-axis. And from there, I am going to go down 1. Always put the negative with the numerator. Down 1 and right 4. So down 1, right 4. 1, 2, 3, 4. Here's a new point. I could go down 4, down 1, right 4. 1, 2, 3, 4. It's about there. Now, here's the difference between an equation and an inequality. This is less than. So if I go up the top, I need to do a dashed line. So take your ruler. Did you guys get the rulers? Where is the rulers? Did you guys get rulers at all? Oh, these girls did not get rulers. Can we pass that back up here? And we are going to draw a dashed line like this. Okay, so make sure you leave some spaces in between. Dashed line. And it says is less than, so I am going to shade below. Okay, and that's why we do this in pencil. All right, so to answer this, it is a dashed line, and we shade below because it was is less than. Okay, now question. Are these points that we just did, right here, right here, right here, are they part of the solution? Because what we have shaded, this down here in the shaded part, that is the solution. In other words, I could take any point in here, substitute it in, and it would make that true. It would make that inequality true. What about these points on the dashed line? Are they part of the solution? Yes. I have some yeses, I have some nos. I need a tiebreaker. Are these values on the dashed line, are they part of the solution? No, yes, no, yes. They are not, okay? So you might want to write this down. Points on a dashed line are not part of the solution. They only guide us into creating that dashed line, okay? But if I put that number in there, that was 3, right? That's 0, 3. Just take a look, and I'm going to do a check here. If I put in the value 0, 3 in for this inequality, where'd it go? Y, oh, I got to put it in here. I'll start first. Y is less than negative 1/4 x plus 3. So if I choose that note, my y value is 3. Is 3 less than negative 1/4 times 0 plus 3? Well, here's a 0. Is 3 less than 3? Is 3 less than 3? No, so that's why it doesn't work. And those are not part of it. Good morning. Okay? They are not part of the solution. Any questions on that? Dash line, not part of the solution. All right, example 5. Hopefully yours is on the same page. Mine is not. Let's go to the next one. Says, graph y is less than or equal to negative 1/2 x plus 3. Put in slope-intercept form. Slope-intercept form. Okay, so I'm going to write this. Y is less than or equal to negative 1/2 x plus 3. All right, are you ready to put it in slope-intercept form? Yes, good for you, Miss Ashley. It's already in slope-intercept form. Here is your slope, and here is your y-intercept. So I have a slope of negative 1/2, and I have a y-intercept of 3. All right, when we're graphing, whether it's an equation or an inequality, start with that y-intercept. 3, 1, 2, 3. There's your first point. So plot this first. And then negative 1, that's going to be down 1, right 2. Down 1, right 2. And from your new point, down 1, right 2. Okay. Now be careful. This is an inequality. So you've got to pay attention. This is less than or equal to a dashed or a solid line. Solid line because it's got similar to the equal sign. So draw your solid line. Okay, so that is a solid line, and we are shading above or below? Below, because this is less than. Is less than. Is less than. All right. Question. Are these points part of the solution? This is a solid line this time. What do you think? Yes? What does anybody else think? Is this part of the solution? In other words, if I put these values in, would they satisfy that inequality? A solid line is just like an equation. The answers for an equation are on the solid line. So the answer is yes. Yes, it would be part of the solution because it is, yes, solution, solid line. Just like an equation. Now, sometimes you might make a mistake and do the wrong half. So we can check this very easily. And you know what point I like to check with if it's part of the solution? Because all of this that's shaded is also part of the solution. So I'm going to pick the value 0, 0. So I start with my inequality. Y is less than or equal to negative 1/2 x plus 3. If 0, 0 is on the correct side of the solution, if I substitute that in, it should make the inequality true. So y is 0, because I'm using 0, 0. Is 0 less than or equal to negative 1/2 times 0 plus 3? Well, anything times 0 is going to cancel out. So is 0 less than or equal to 3? Yes. So I know I have shaded the correct side. That's how you can check. Okay? Any questions on that one? Okay. So, last problem says put the inequality into slope-intercept form. So I'm going to rewrite it first. 4x minus 2y is less than or equal to 8. Now this is a check, meaning you should try to do it on your own. But remember, we want to get it to y equals mx plus b. That is your slope-intercept form. So we want to get that y by itself. Okay? See what you can do to get this problem started. All right? See what you can do. I'm going to walk around and check. You want to get the y by itself. Yeah, look back in your notes, maybe the page before, and let's